Let's see how we can create a basic malicious Windows executable using the MSFvenom tool. 64-bit Windows 8 is the victim system. Choose an executable to use as a template. The output malware will be the same size with this template file. I'm going to use putty.exec file as the template. Let's copy putty.exec to Kali to work on it. First, look at the IP address of the target machine here, Kali. You can use WinSCP tool to transfer a file from a Windows system to a Linux system. SCP, Secure Copy, is a means of securely transferring computer files between a local host and a remote host, or between two remote hosts. It's based on the SSH, Secure Shell Protocol. Now, since WinSCP uses SSH protocol, you'll be sure the SSH service is running on Kali. Check the status of the SSH service using service SSH status command. It's already active on my Kali. If it's not running, use service SSH start to start the SSH service in your Kali machine. If you try to log in WinSCP using root user, you may see the access denied message. That means using SSH service with root user is denied in your Kali machine's SSH service configurations. Either change the SSH service config to be able to connect with root user or create a new user to use SSH connections. I choose to create a new user. You can use add user or user add commands on the terminal screen, or users interface to add a new user. Now, I've already added a user before SSH user for this purpose. You can add a similar user to your system. Connect WinSCP using SSH user credentials. Find the exec file at the Windows side. In this example, it's on the desktop of a current user. Copy it to the Kali machine, in here, to the home folder of SSH user. In Kali, use is command in the terminal screen to see if the file is transferred successfully. Now we're ready to create a malicious executable using the putty.exec file as a template. Prepare the appropriate MSFvenom command. The first parameter is -p, which specifies the payload used. You have to find a correct payload according to your target. Don't forget to choose a payload with the correct platform, correct architecture, correct connection method, etc. You can see the available payload using MSFvenom-L payloads command. There are a lot of payloads available, and since the target machine is 64-bit, we can filter the results using grep command with pipe. We use the Windows/x64/meterpreter/reverse_TCP payload for this example. Let's have a pause here and have a small introduction to the world of Metasploit. Metasploit project is the most used penetration testing framework in the world. It can be used to test the vulnerability of computer systems or to break into remote systems. Metasploit was created by H.D. Moore in 2003 using Perl. By 2007, the Metasploit framework had been completely rewritten in Ruby. In 2009, the project was acquired by Rapid7. Now they have a free and open source version, Metasploit framework, and a commercial version, Metasploit Pro. Its best-known sub-project is the open-source Metasploit framework, a tool for developing and executing exploit code against a remote target machine. The MSF console is probably the most popular interface to the Metasploit framework, MSF. It provides an all-in-one centralized console and allows you efficient access to virtually all of the options available in the MSF. MSF console may seem intimidating at first, but once you learn the syntax of the commands, you will learn to appreciate the power of utilizing this interface. Meterpreter, short for the Meta Interpreter, is an advanced payload that is included in the Metasploit framework. Its purpose is to provide complex and advanced features that would otherwise be tedious to implement purely in assembly. The way that it accomplishes this is by allowing developers to write their own extensions in the form of shared object DLL files that can be uploaded and injected into a running process on a target computer after exploitation has occurred. Meterpreter and all of the extensions that it loads are executed entirely from memory and never touch the disk. Let's continue to create a malicious executable using the MSFvenom tool. Now, the first parameter was the payload. We can choose the platform here, Windows, but since we chose a Windows payload, the tool will already understand the platform. Same as the platform, we can set the architecture x64 using the -arch parameter. Because we use a payload for x64 architecture, the tool will already understand the architecture, so we don't need to use arch and platform parameters in this example. The next parameter is -f to determine the format of the output file. Now, you can use MSFvenom -help -formats to see the available formats. We only use the exec in this example. Then specify the template file using a -x parameter with the template file. Name the output file with the -o parameter. Now is the time to define the options of the payload. To see the options of the payload, you can use the -payload -options parameter with the payload. We have to assign the lhost and the lport options of the payload here. Complete the command again, output file format, template file, and output file name. Now assign lhost and lport options of the payload. Lhost is the IP address of the listener machine, in this example our Kali machine. Lport is the port which will be open to listen to the sessions. Hit Enter to create the malware. As you see, no arch is selected. The tool selected x64 from the payload, and no platform is selected. The tool automatically selected Windows from the payload again. To be sure, go to the folder and see the created malware. The attacker should find a way to make the victim accept and run the malware. Let's just copy the malware to the victim's machine at the moment, and suppose that we send it as an attachment to a phishing email. First, let's try to copy the file to the Windows machine while Windows Defender is running. As you can see, Windows Defender recognized the malware. And deleted it in seconds. Can you guess why? Because we used a standard Metasploit payload which is very well known, and Windows Defender recognized it easily. To see the payload in action, let's turn Windows Defender off and send the malware again. As an attacker, we need to listen to capture the sessions of the victims who run the malware. Start MSF console. You'll have a Metasploit framework shell. Search for the handlers. Use exploit/multi/handler for this example. In Handler, we have to use the same payload that we use in the malware. List the options with Show Options command. Set the listener address and port. Since the default port is the same with the port we assigned in the malware, we can leave it as is. And run the handler, it starts to listen at that moment. Now go back to the victim machine and run the malware. Voila! We got the session from the victim machine. Look at the system info using sysinfo meterpreter command. It's a 64-bit Windows machine. Look at the user ID. Meterpreter has a lot of excellent commands to compromise the victim's machine. Use help command to see some of them. Let's take a screenshot of the victim machine. When we list the currently running processes using tasklist command in the victim machine, we see the malware running. You can kill it using the taskkill command with /PID parameter. Use /F parameter to force it to be killed. As soon as the malware process is killed, the meterpreter session dies as well.